magnetic field time graph, this would just be the rise over run or the slope. Yeah, take a chance.
B sub 0. Okay.
We're doing it with respect to time.
Omega.
Close.
Negative omega?
Negative omega. Then,
Sine.
close.
Negative sine.
Yes, negative sign. And then all that stuff. Let's hope those negative signs all cancel out. Well, let's see, got that negative and that negative cancel out, and then that negative and that negative cancel out. That was lucky. Hey, what else cancels out? Yes. This whole bit right here goes away. And I am left with a very simple, the magnitude of my, or amplitude of my electric field times the wave number is equal to the amplitude of my magnetic field times the angular frequency. All of that just come out with a simple 4 or 5 symbol equation. We can take it one step further. If I bring K over to the right-hand side and B sub naught over to the left-hand side, I get E sub 0 over B sub 0 is equal to omega divided by K. And what is omega divided by K?
Speed.
Yes, right there. So I now have at least a relationship. It doesn't quite narrow down for an exact number yet. But I have that the speed is equal to whatever the amplitude of my electric field is divided by the electric field, or the magnitude divided by the amplitude of my magnetic field. Make sure this thing is still going. We are halfway there. But once we've gone through one of them, the other one's simple. Matter of fact, when I asked for, we'll end up with a delta V over delta X and a delta E over delta T, you'll be able to do it in unison. I will weep inside at how beautiful it will be. All right, questions? Because I need the space, I'm gonna erase some stuff here. We'll be using the Ampere-Maxwell's law. All right, so first off, Ampere's-Maxwell's law, we're not dealing with any moving charges. These are just electric and magnetic field. And so this term is 0 just because there's no charge moving. Now, the electromagnetic wave might have been started by a charge moving, but we don't care about how it started. All right, so I need to create an Amperian loop here. Or a Gaussian loop, or a Faradayan loop, or whatever they want to call it. And I should still not use a marker on this. I want to create, again, a rectangle here because I'm going to be doing B dot delta L around some loop. And so I'm going to do it here. So I start out with my electric field up and my magnetic field out. And I did a rectangle right here. Now I'm doing a rectangle on the horizontal piece of it. So basically we're going to end up getting magnetic field here. We're going to look at it like that. So I'm going to have a square here. My magnetic field, the electric field is going away from me. draw up a rectangle. The electric field is going away. This is my electric field. I know that my magnetic field has some value here of B, and over here, some value of B plus some change in B. I'm going to start in the lower left-hand corner. This time when I do my loop, since my electric field is going in right-hand rule, I'm going to go around clockwise this time, so this is going to be A, B, C, and D as I go around that loop. Oh, the dimensions of my box, delta X horizontally and H vertically. Same as I did before. And so this becomes B along the A dot delta L along A plus B along B dot delta L along B plus, well, the C1 plus the D1. That's going to be equal to mu sub naught epsilon sub naught times the change in my electric flux over time. Same expansion that we did last time, except for the flipped field, or the other field. All right, we've done this before. Let's start doing the loop. What is, for that first segment, A, what is B dot delta L? Units would be really cool right now. I guess you just don't want to be cool.
B times H.
Yep. What about along the B segment? What's B dot delta L along my little B segment?
0.
Yes. Along the C segment?
Negative B plus change in B times H.
So minus B plus delta B times H. And then in my last segment?
0.
Yep. And that's going to be equal to, again, E and A, I'm going to put them in the same direction. So A is just going to factor out, and I'm left with mu naught epsilon sub naught A delta E over delta T. I think I worded that badly. E and A are in the same direction, therefore my dot product is just the product of the magnitudes. A is constant, so I'm pulling it out. And now let's simplify. I have BH minus BH minus H delta V equals mu naught epsilon sub naught times my area, which is just the area of this rectangle. So that is H delta X times delta E over delta T. Oop. Okay, no. Let's say I lost a minus sign, but I did not. Simplify it. What's next? What can we get rid of?
Times H.
All right. Anything else?
H.
And so I'm left with negative change in B is equal to mu naught epsilon sub naught delta X delta E over delta T. Just like before, we're going to bring the delta X over. And so I get negative delta B over delta X is equal to mu naught epsilon sub naught delta E over delta T. And as before, if only we had a formula for the magnetic field versus position, then we could find my rise over run or the slope. So what is, and this is the point, unison. Man, that would be so incredible. It's recorded. You'd be hailed throughout history for doing this. Negative delta B over delta X is, I'll start you out, negative. All you have to worry about is the delta B over delta X. Now I know Olivia knows it. I was hoping someone else would take a shot. Don't make me have her put you out of your misery. You know what? If you have the patience, just sort of wait, let someone else take a shot at it. I'm just gonna sit down and wait for someone to tell me, or at least take a shot at it. If you make a mistake, that's okay.
Would it be negative B sub naught times K?
When you said negative, you're including this negative, is that the negative you said?
Yes.
Okay. B sub naught K.
And then it would be for the other side.
Oh,
East.
let's finish this side first. Got the cosine piece. What does that become? Close.
Negative.
Negative sign. All right, negative sign of all of that. Equals. Now the right-hand side, let's see if we can get a new voice, someone else taking a shot at it.
Negative E sub naught K, no,
With time.
negative omega,
But where does this, you said negative to start out with, where does that negative come from?
negative B sub naught.
No, that negative's there because of this negative. There's no negative in front of this.
Because we're doing the inverse.
All right, let's just, I'm gonna erase this for right now and actually stick in the mu sub naught, epsilon sub naught that we ignored. All right, so we got E0, we got the negative omega because that's in front of t, and then what comes next?
Negative cosine, negative sine.
Negative sign of all of that. That's, I wasn't sure whether you threw that first negative in because you had already accounted for that one, or whether I was gonna get an extra negative sign at this point. And we are in luck. The minus signs all cancel out. I got a negative sign there, and then here, so we don't have to worry about that pesky negative sign, which for many years was the bane of my 152, 252 existence. All right, what else can we get rid of?
Sine.
Yep. And so we are left with a very simple B sub 0, the amplitude of the magnetic field, times the wave number is equal to the permeability of free space times the permittivity of free space times the amplitude of the electric field times the angular frequency. We're trying to find the speed of this wave, and so I'm going to solve for omega k, so I'm bringing k over here, and I'm bringing this over to this side. So omega over k, which is speed, is b sub 0 divided by mu sub naught, epsilon sub naught, e sub 0. This does not contradict what we have before. It complements it. So I now have e sub 0 over b sub 0, that's what we got the first time. That's got to be equal to, if this has any validity, to b sub 0 over mu naught, epsilon sub naught, e sub 0. Questions here before we finish this off and come up with why this is so incredible in reality? This had a huge impact.
What did you say B naught and K mean?
K is the wave number. If you think of period as the number of oscillations per second, the wave number would be the number of oscillations per meter. And by the way, the wavelength of a microwave, just to give some context, a microwave wavelength's about like that. Light, visible light, is on the order of just shy of a micrometer or micron. All right. Anything else before we come up with a huge impact here? I'm going to multiply both sides by e sub naught over b sub naught. In other words, I'm taking e up to there and b down to there. So I get e sub naught 0 squared over b sub naught 0 squared is equal to 1 over mu sub naught epsilon sub naught. I know e sub naught over b sub naught is just the speed, so I'm going to take the square root of both sides. And so I get e sub naught over b sub naught, which is equal to the speed of this wave, is equal to the square root of 1 over mu sub naught epsilon sub naught. Theoretical speed of electromagnetic wave. U sub naught. What is the value of mu sub naught? That's a pi there. Given units? Anyone want to come to a rescue? Or just leave her hanging? Decimal meters per ampere. All right. Permittivity of free space.
8.85 times 10 to the negative 12 coulomb squared divided
Yep. So if someone would be kind enough to actually multiply them together, take their reciprocal and then the square root, what do you get? believe in you.
Three times 10 to the power of 8.
Say it again?
Well, 2.998 times 10 to the power of 8.
Units? Oh, don't think too hard. Don't psych yourself out because of the strange units here. Say it again?
Meters per second.
Yeah, meters per second. Because clearly, the square root of 1 over a Tesla meter ampere times Coulomb squared Newton per Newton meter squared, that's clearly a meter per second.
Obviously.
I know. I shouldn't have even written it down. If you went through, it does work out. I'm not lying to you here, and Olivia's not lying to you either, because she's the one who said meters per second. But it is meters per second. All right, so Maxwell gets this value. This is the 1870s. We are still recovering from our Civil War. So American physics pretty much zip right now. So he's British. He comes up with this. At that point, the accepted value was somewhere around 3 times 10 to the 8th meters per second. It wasn't exact, that it was basically had been found through experiment. And he comes upon this, and he comes up with the suggestion that it's too much of a coincidence that this value of the speed of the electromagnetic wave is too much of a coincidence that it's close to the found speed of